Hello everyone. So this is a question from JEE Mains 2026, 6th April Shift 2. 500 ml of 0.2 molar MnO4 minus solution in basic medium when mixed with 500 ml of 1.5 molar Ki solution oxidizes the iodide ions to liberate molecular iodine, and this liberated iodine is titrated with a standard X molar thiosulfate solution in presence of starch as an indicator till the end point. If 300 ml of thiosulfate was consumed, then the value of X is. So basically they are asking us the molarity of the thiosulfate solution. Okay. So the chapters involved is redox reactions, some basic concepts of chemistry. Okay. So according to the law of chemical equivalence, gram equivalence of each of the reactants is equal to the gram equivalence of each of the products. Okay. Very important. Products. Okay. So for a reaction, let's say, that it's not balanced. Okay. A plus B giving me C plus D. Okay. So according to the law of chemical equivalence, I can say that gram equivalence of A is equal to gram equivalence of B is equal to gram equivalence of C, which is equal to gram equivalence of D. Okay. And this is very helpful because we don't need the balanced equation to apply this law. You can see this is not a balanced equation. Okay. And to calculate the gram equivalence of a substance, we know that normality, which is one way to express the concentration, is equal to gram equivalent of solute divided by volume of solution in liters. Okay. And we also know that normality is equal to n factor into molarity. Okay. So therefore I can write, substituting this value of normality in this equation, that n factor into molarity into volume of solution in liters is equal to gram equivalence of the solute. Okay. And to calculate the n factor for a oxidizing or a reducing agent, so we use the formula n factor is equal to magnitude of final oxidation state minus initial oxidation state. To take the magnitude into number of atoms changing state. Okay, so we'll see how to apply this formula, and using these prerequisites, now we can solve our question. And it is given to us that 500 ml of 0.2 molar MnO4 minus in basic medium is mixed with 500 ml of 1.5 molar Ki solution. Okay, one thing we should know is MnO4 minus in basic medium gets reduced to MnO2 ultimately. That is what we should know. Okay, and therefore with respect to reactions, I can write MnO4 minus plus I minus, it comes from the Ki. I will get obviously I2, and as I mentioned, MnO4 gets converted to MnO2. Okay, so no need to balance this. So let's calculate the gram equivalence of MnO4 minus and I minus. Using the formula, we know that n factor into molarity into volume of solution in liters will give me the gram equivalence. Okay, so for MnO4 minus, you can see it is changing to MnO2. Okay, so let's calculate the oxidation state of Mn. X plus 4 into minus 2 will be equal to minus 1. So therefore x is equal to plus 7. Here x plus 2 into minus 2 will be equal to 0. So therefore x is equal to 4. Okay, so therefore n factor is going to be magnitude of 4 minus 7, final oxidation state minus initial, and its magnitude into 1. Okay, because 1 Mn atom is there in the reactants. So this will be equal to 3. Okay, so therefore the gram equivalence of MnO4 minus is going to be, n factor is 3, molarity is given to us as 0.2 m, and the volume of the solution is given to us as 500 ml. So converting it into liters, so this will be the n factor of, sorry, this will be the gram equivalence of MnO4 minus. So if when you calculate this, you will get this as 0.3. Okay, for I minus, it is changing to I2. Okay, in I minus, the oxidation state of I is minus 1, and in I2 it is equal to 0, because oxidation state of atoms in elementary state is equal to 0. Okay, so therefore n factor will be equal to final oxidation state minus initial oxidation state magnitude 0 minus minus 1 into 1. Okay, 1 because one iodine atom is there in the reactants, so therefore n factor is going to be 1. So therefore the gram equivalence of I minus will be equal to 1 into 500 by 1000, the volume given to us is 500 ml, into 1.5 molarity. So this is equal to 0.75. Okay, so I will write this down. So gram equivalence of I minus is 0.75, gram equivalence of MnO4 minus is 0.3. Okay, so you can see MnO4 minus has lesser amount of gram equivalence, so therefore it is the limiting reagent. Okay, so MnO4 is the limiting reagent, and so therefore 0.3 gram equivalents of MnO4 minus will react with 0.3 gram equivalents of I minus to give 0.3 gram equivalent of I2. Okay, so therefore you can see I minus is clearly in excess. So therefore 0.75 minus 0.3, that is 0.45 gram equivalents of I minus will be left unreacted. Okay, because 0.3 gram equivalents of MnO4 minus will react with 0.3 gram equivalents of I minus. Rest of it, that is 0.45 gram equivalents of I minus, will be left unreacted. Therefore, the most important information for us is that 0.3 gram equivalents of I2 is formed. Okay, so this 0.3 gram equivalent of I2 is titrated with X molar thiosulfate solution in presence of starch as an indicator till the endpoint. Okay, so if I draw the apparatus, it will look something like this. So we will have the burette, which contains thiosulfate solution, and in the flask we'll be having the iodine solution, and we add starch as an indicator, so it's a dropper. Okay, so we have one information that the gram equivalence of iodine in the iodine solution is 0.3. Okay, so starch reacts with even trace amounts of free iodine to form an intense deep blue black complex. An endpoint is reached when even the last bit of iodine reacts with the thiosulfate solution, causing the blue color to completely disappear. Okay, so that's why starch is used as an indicator to find out when the reaction has been complete, when there is no iodine left. Okay, so with respect to reactions, we have to know that thiosulfate ion gets oxidized to tetrathionate ion. Very important. Okay, thiosulfate ion gets oxidized to tetrathionate ion by the iodine. Okay, so with respect to reactions, I can write I2 plus the thiosulfate ion formula is S2O3 2 minus iodine is converted to iodide, and thiosulfate is oxidized to tetrathionate ion, and the formula of tetrathionate ion is S4O6 2 minus. Okay, at the end point, all the iodine has combined with S2O3 minus, obviously, right? So therefore, at the end point, I can say that gram equivalents of I2 will be equal to gram equivalents of S2O3 2 minus, and we have already calculated the gram equivalence of I2, if you remember, which is equal to 0.3. Okay, so therefore we have to calculate the gram equivalent of S2O3 2 minus. Okay, so as you can see, it is changing to S4O6 2 minus, that is thiosulfate is changing to tetrathionate ion. Okay, so let's calculate the oxidation state of sulfur. So x 2x plus 3 into minus 2 will be equal to minus 2. So 2x will be equal to plus 4. So x will be equal to plus 2. Okay, here 4x plus 6 into minus 2 will be equal to minus 2. So 4x will be equal to 10. X will be equal to 10 by 4, which is 2.5. Okay, so therefore the n factor will be equal to magnitude of final oxidation state 2.5 minus initial 2 into 2, because there are two S atoms in the reactant thiosulfate. Okay, so this is 1. Okay, so therefore the gram equivalents of S2O3 2 minus will be equal to 1 into x molar, which is we are supposed to calculate, and 300 ml volume, so 300 by 1000. So this will be equal to 0.3, because we have at the end point we have already mentioned that gram equivalent of thiosulfate ions will be equal to gram equivalent of I2. Okay, so x will be equal to 0.3 into 1000 divided by 300. So when you solve this, you will get this as 1. Okay, so therefore the molarity of the standard thiosulfate solution x is 1. Okay, thank you.